Enspired. And today he will give us a keynote on applications of machine learning on short-term power markets and its challenges. Peter, can you hear us?
Yes, thank you. Loud and clear. Can
Wonderful.
you hear
me? Loud and clear as well. We already have your slides here. Let's just quickly put them on, and we give you the floor for a couple of minutes. Ahmad, any previous announcements to Peter?
Yeah, thank you very much. Welcome, everyone. So energy trading or energy traders basically analyze production, demand, and price of energy. They use that, of course, to create policy about energy trading. We heard today Christian Kern talking about energy trading, and he said currently only intraday is basically trading is the major trading in energy. We have seen how we can use artificial intelligence recently in trading in general, especially in the stock market trading, for example, using specific algorithms like reinforcement learning. So today we will see an application of trading using artificial intelligence on energy trading. And for that, I would like to welcome our guest from Enspired.
One more housekeeping point. This is live. You can use the Slido or LinkedIn chat function to ask questions to Peter Baumgartl, and we see each other in the Q&A session. Peter, the floor is yours.
Cool, perfect. Thank you for the introduction and thank you for having me. I have to say that I am very glad that the speakers, Mr. Kern and Professor Kupperholz, before me already gave a lot of context that puts what I'm going to speak about a little bit, makes it a little bit more tangible. So my topic is, was said in the introduction, applications of machine learning on short-term power markets. So we heard a lot about applications of machine learning in a distributed grid or in a VPP or the power markets in general, but I'm going to give more in-depth examples. And basically what I'm going to talk about briefly is who is Enspired, so you get some idea about what we do, then what the power markets are in a nutshell, because it's important to understand that in order to understand why use machine learning or what machine learning can be used for. Then I'm going to talk a little bit about the most common machine learning use cases, the more advanced ones and its challenges, and then we have some time for questions. So what is Enspired? Actually, Professor Kupperholz gave a really good perspective of what we do, because if you think about VPPs or also all conventional power stations like renewables or whatever, pumped storages, batteries, it's important that you don't only optimize them technically, but you also optimize them commercially. And that is what Enspired offers. So we are a startup based in Vienna. We got founded 2 years ago, basically. And our offering is trading as a service, which is kind of a new concept. It's a bit like software as a service, but we provide commercial optimization of all possible power assets like renewables, VPPs, whatever you can think of. So I'm going to give you a brief introduction about the short-term power markets, because when you hear about the wholesale market, it always gives off the impression that it's one market, which it really isn't. There's a lot of different markets, and you need to understand a little bit how they work in order to understand why use machine learning and what it can be used for. So the markets start out with long-term agreements, day-ahead trading. So long-term agreements are not really interested, so I'm not going to go into detail about them right now, because they are more for hedging and OTC trading. So the most important part of the power markets, at least on the short term, is the day-ahead auction. And the day-ahead auction is basically an auction that takes place every day, where everybody trades their whole portfolio. So all consumers buy all their consumption needs on the day-ahead auction. All producers sell their whole production on the auction. And it's just a blind auction where everybody says, like the producers say, I can produce at price, I don't know, 150 euros at the moment, maybe for a coal power plant. They say, if the price is above that, I'm going to sell. The consumers say, I'm going to buy. And that's how the power prices are made. So it's very important to understand that after the day-ahead auction, basically everybody already bought and sold everything they need. So you should have no position left. You should have sold all your production. And in the past, this was also when the market ended. But all that changed logically when renewables came into place, because as you can see, it takes place before the power gets delivered. So for renewables, you can only sell your best forecast or your best idea of what you're going to produce in this auction. That means there was a need to introduce some new markets a couple of years ago, which was, first of all, the intraday auction, which has a finer granularity, so where you can trade 15-minute products. So that means that you can balance your ramps and up ramps and down ramps of your renewable portfolio better. And then the continuous intraday market. So far we talked about two auctions. The continuous intraday market is what you think about, like it has the same design than when you think about like markets like a stock market or the crypto market or whatever. The continuous intraday market has the same design. So it's traded. It's not an auction, but it's like live trading. Everybody puts up bids and offers. They get updated all the time. It's going to be important a bit further out. Then delivery happens. But still, if you have positions left over, there's a market after that. It's a bit of a funky concept, which is the imbalance market. And that is where the power grid balances the grid. So the grid can work at 50 hertz. So this is for technical reasons, because power needs to flow and the grid frequency needs to be 50 hertz. But for this presentation, you can think about it as an additional auction, basically. So why do the short-term power markets exist? I described it briefly before. So basically what happens at the spot auction is that you sell your best known renewable forecast. I mean, you have a wind farm, you know it, you think it's going to produce 10 megawatts, then you sell 10 megawatts. But what happens is time goes by and your forecasts become better and better. And then in the end, you need to have sold your actual production. So you need to trade back and forth to hit your actual production as good as possible. And here on the left-hand side, we see like the day ahead forecasts that the producers of renewable energy would sell. And on the right-hand side, you can see it with the dotted lines being the actual production. So on the short-term power markets, the difference between the forecasted renewable production at 12 o'clock on the day before and the actual renewable production needs to get traded, because otherwise there's too much or too little power being produced. Who's on the other side of these trades? On the other side of these trades are conventional power plants who then turn off their power plants, or if there is too much renewable power, or turn them on if there's too little renewable power. So this is the whole idea behind the intraday market. And if you think about this a little bit, then it becomes quite clear that if there is more renewable production than was expected on day ahead, the prices go up. If there is less renewable production, the prices go. If there's more renewable production, the prices go down because there's more supply. If there's less, the prices go up because there's demand to buy back the missing power production. So here we can see an example of how this looks ex post for a trading day. You can see in blue the renewable delta from the day ahead auction. So this is the actual renewable production compared to what was sold on the day ahead auction. And in pink, you can see the price movements on the continuous intraday markets. And you can see this almost always fits. So in the first part of the day, we had too much renewable, or we had more renewable production than was expected. So prices go down. Then we had a large solar surplus, I guess, because it's in the middle of the day. So prices go up, and then in the evening they go up even more because, I guess there was very little power in the stack. So normally ex post, you can always see this pattern: too much renewable production, prices go down; too little, prices go up. So how does this translate into machine learning use cases? In the end, data scientists sound stupid, so they do whatever is easiest first. So the most common use case that you're going to see when you walk into basically any trading house that works with the intraday market is you're going to see auction versus auction use cases. Why is that? Because auction versus auction is very simple. Auction only has one price. It doesn't change, like it happens at a certain point of time. there's one cutoff. It has one price. So we can try to predict before auction takes place if the later auctions are going to trade up or down. So what happens is basically that people develop machine learning models that predict the spread between two auctions. So that might be the day ahead versus the intraday auction. And then you predict, okay, is the intraday auction going to come out higher or lower than the day ahead auction, and take positions based on that. So in trading, it's always a bit tricky which machine learning models you use. I wish I could say, because I know it's the hottest topic, that everybody uses neural networks and whatnot, but actually it's very uncommon to see that happening. So normally you use more traditional techniques like binary classifiers, random forests, XGBoost, so boosting trees, to forecast the direction, because as a trader, basically, I mean, you are interested in how much it's gonna deviate, but you make money when it goes higher or lower. So basically, a binary classifier is all you need. So that is what we see used a lot, basically in these cases. So then there's less common use cases, which I'm going to go to in why they are less common in a second, which is auction versus intraday. The principle is the same. You take a position, you have your machine learning model running here, and you think about, is the intraday continuous trading going to trade higher or lower than these auctions? You take a position accordingly. But what you need to do is you need to model the intraday continuous market as an auction kind of, so it only has one price, because otherwise it's going to be very tricky. Like there is hundreds and thousands of trades in every product on the continuous market. So you need to do something to make it that the machine learning models work exactly the same way as your models worked in the first use case, which is taking, for example, the volume weighted average price of the intraday continuous market as a point where you calculate the spread between the auction and the volume weighted average price. There is a reason why this is less common than the other one that I was talking about, and that is because you also need to execute a lot of trades on the intraday market, which means that to do this, it is kind of mandatory that you have algo trading. Like we heard from the speakers before, the energy market is kind of old school, so they are also not very fond of algo trading, I would say, or a lot of people are not so fond of it. And I mean, in essence, a regular trader could trade out these positions, but they are very, very bad at hitting the average price, and they hate doing something like this. So humans are very bad at doing at following just the orders from a machine learning model. This use case kind of forces you to have algo trading in place. Yeah. So now, when I think the smart listeners, if they thought about it, were thinking like, what happens if you have better forecasts than everybody else, then you can correctly predict the price movements, right? Unfortunately, there is one pitfall here, which has to do something with every kind of trading, is if you are the only one that has better forecasts, the market will not react to it, right? Because the prices only fall and fall and rise if all market participants agree that this is a fair price. So if you are the only one that thinks that has this information, nobody else is going to act on it, and the markets will not move. So this is like one of the first pitfalls where you have to have a little bit of understanding of how markets work in order to get that right. So unfortunately, better forecasts for trading alone don't help you that much. If you manage a renewable portfolio, they help you, of course, but for trading alone, it's not so beneficial. So now let's talk a little bit about more advanced use cases that you will not see in the industry a whole lot, because it's only like companies that are focusing almost solely on that employ these because it's rather resource intensive and complicated, which is intraday versus intraday trading. So why is this the more advanced one? Me and a mate in my team were talking the other day, and then we came to the conclusion that it's like an onion. So trading intraday versus intraday has a lot of layers, and the more layers you unveil, the more you want to cry. So I'm going to talk a little bit about why this is so complicated to trade intraday versus intraday. So basically, the first thing that you need to consider is there is a lot of data. So humans, human traders look at screens like this all day, and they don't have one screen like this, they have 12 screens like this. So you have huge amounts of data in contrast to other machine learning projects. All the data is very clean and very nice, which is cool. But the problem is that your signal to noise ratio is very low. That means even though you have this huge amount of data that you can use for your machine learning models, it's very hard to get proper forecasts out of it. And that has also something to do with how trading works. And that is only like the market participants don't behave all the time like the data would indicate. So it's still humans sitting behind the screen, and they don't necessarily have to behave like what is the best way or what is in their best interest. So this makes it so difficult to have a like really good hit rate. So when you talk about other classification problems, you read a lot in literature like 90% hit rate, 95% hit rate, 99% hit rate. This is impossible to achieve in power trading. So we are very happy when we get to 60% hit rate with our models, so being right 60% of the time. And that is simply because even though you have this huge amount of data, it's very hard to generate signals out of it because, like I said, the human traders on the market don't necessarily behave like what in what is the most economical way. The second problem that kind of comes with trading intraday versus intraday, you can see here. So this is a chart where you can see like all the little bubbles are trades that are happening on intraday. This is just a 2-hour window from one product that I picked out, and the lines are like the order book data. And you can see here the market alone has massive amounts of data. So every trade, every change in the order books is like a new data point that you have to process. And like I explained, on the intraday markets, fundamentals play a massively important role. So now it becomes even worse. So every 15 minutes, a new renewable forecast is published. So basically, you have to process this data in real time. Like every change in the market can make the market move. You have to be super fast to process this. And so we have new renewable updates every 15 minutes. And then it becomes even worse because then we have the publication of imbalance data, which looks, then we have, sorry, mixed it up. Then we have big weather model runs, which are like EC or GFS or whatever, which is the big international weather models that also like change the renewable forecasts. And then the worst thing is the publication of imbalance data, which has a huge influence on the power markets. And unfortunately, it's not like I'm not very good at making PowerPoint presentations. So, but these errors are so irregular. So they don't even have a regular publication schedule. They get published every like 5 to 10 minutes, and new information gets published. So it's very hard to model this market in a sense where I can say, okay, my machine learning model is gonna run here, for example, or here or here or here, because like if there is data that gets published only like 10 seconds after your machine learning model ran, your machine learning model might be wrong already. So this is one of a very big challenge. And then the third really big challenge is that the power markets have massive amounts of structural breaks. Like if you know about machine learning, you know you need lots a big amount of data to train your models properly. So normally you use years of data to train your model, but there is so many structural breaks. And if you only look at the data of the last year, I mean, I plotted the spot prices here for the last year. So you can see this looks very static or nice and well. And then all of a sudden, last autumn, the energy crisis started. And we can see prices going more erratic. Then in January, Germany continued with its nuclear Ausstieg. So I don't know what it's in English. I'm sorry. I think it's nuclear exit maybe. And also the Kohleausstieg. So the market changes in a fundamental way, which means you always have to ask yourself the question, can I still use the data that I have for training? Is that still relevant for my prediction that I'm doing now? And then, unfortunately, as we all know, the war in Ukraine started this month, which also had huge impact on the power markets, which is another structural break that is very, very hard to deal with. So this is why for commercial optimization on the markets has a lot of challenges when you talk about intraday versus intraday trading, or when you talk about trading on the continuous markets in general. And yeah, this is why not a whole lot of people do it. Yeah, that's basically it. So, time for questions.
Thank you so much, Peter, for the great presentation. We have a very active and knowledgeable audience today and received some relevant questions. And now is the time actually to upvote the questions and maybe additionally ask more questions that are on your mind. Ahmad, what do we have as the most popular question to Peter Baumgartl from Enspired?
Yeah, the first question, which is actually important to me as well. So in summary, how can you improve the accuracy of your predictions? What do you need more? Like more data, better models? What more?
In essence, it's a bit tricky because when you think about other sectors, then you can implement a machine learning model. I mean, it might get outdated, so other models get published that are more accurate. But in the power markets, it's like your performance. Like you take a model live, and then your performance starts to decrease because of all the structural breaks and stuff like this. So you need to put a lot of maintenance into your machine learning models. You always need to check if they are still valid or if they are not valid. And B, what is really, really important is that you understand the mechanics of the power market. So you need to understand, for example, I give you an example, like in Germany, you would think load or power demand is always very important, right? But as a matter of fact, in Germany, on the intraday market, it makes no difference what the load does because of the way that the market is structured. So you need to try to remove all the noise that has no influence on the market. You need to understand what moves the markets really, remove all the noise out of your machine learning models or out of your data, actually. So feature selection is like one of the most important things, even with models that use regularization. I never can say this word. Even with models that use that, feature selection is the most important thing. And to do that properly, you really need to know about what moves the power markets.
Thanks a lot, Peter.
Just one maybe addition from my side. Do you consider like external factors, like, I don't know, use social listening? Because we are in time of uncertainty, right? So not only the historical data of IoT or of sensors can help, maybe some scraping or doing social listening on news articles, tweets, I don't know, to improve the performance. Are you considering such data in general?
So in general, you would need to consider this if you would trade on the long-term markets where you trade like further ahead. So we only trade the next 24 hours when news don't have that much of an impact. I mean, the news that considers us the most, if you can call it news, is if a power plant fails, which happens from time to time. But if you would trade on the long-term market, so years ahead, then news about policy are really important, like coal and nuclear Ausstieg. If you trade like months ahead, then it's really, you need to always be like the stuff like turning off Nord Stream 2, you always need to be like really ahead of that and be aware of that, and also maybe intervene in your models manually. Because if there's nothing in the data that indicates that it's going to continue, that indicates like these big changes, then you need to intervene manually, basically.
Right. Moving on to the next question, and this really targets your augmented trading community. Who are typically the customers of your solution, and how difficult is it to convince companies to use an AI solution? Can you share 1 or 2 sentences about that?
Yeah, definitely. So our typical customers are actually companies that own big assets themselves, like wind farms, or own or manage, because sometimes there's also subcontraction, but that own or manage big assets themselves, and they want us to help them like with the commercial optimization. It is a matter of fact that the power trading business is a really cold business where cash is king, basically. So people don't really care about so much what you use to optimize the asset. I mean, we chose the machine learning approach because we see it as the future. But if you can beat benchmarks, so can you beat human traders? So in that sense, you can only convince people with performance, but that also means that you have to put in a lot of work before you can convince a customer, because you have to prove to them that that you can beat their current performance.
Thanks so much, Peter, and for your insights from Enspired. We are already a little bit behind schedule, so if you have any more questions to Peter, please join the networking and try to contact him and his colleagues there. Wishing you a nice day, and hope to talk to you soon, Peter. Thank you.
Yeah, cool. Thanks for having me.
Thank you, Peter.